Time to dive in again. You better be ready. I'm ready. Let's go. So in this video, we're going to talk about how to calculate limits at infinity, specifically how to do it with our brains conceptually, and we're going to work in graphs a little bit too. Let's check it out. So this problem says find each limit. What did we find on the function's graph? Okay, well, how are we going to do this? Well, we're going to do this conceptually. We could also do it graphically too. So conceptually, what's going down? The limit as x goes to negative infinity. Now I'm going to go over the informal way of doing this for most of this lesson. We'll do it formally at the end. So what I do is I do 2 plus 1 over, and I plug in negative infinity. You can't plug in a number that's not finite technically, but I want you to follow my logic on this. You've got 2 plus 1 over huge, massive, right? Negative infinity squared, or a negative number squared, is positive. And that's basically 2 plus 0. Why is that? If I have $1 and I divide it among 5 billion people evenly, we essentially each get nothing. So when you divide 1 by a huge denominator, it's basically 0. So that's equal to 2. And there's our limit. That's it. If you take a look at the graph of 2 plus 1 over x squared, check it out. As we go to the left to negative infinity, we are approaching a y value of 2 right there. Nice. Now the limit as x goes to positive infinity of 2 plus 1 over x squared. Again, what I like to do is I plug in, again, this is an informal way of doing things, 1 over infinity. Well, plug in infinity. 1 over infinity squared, well, that's essentially 2 plus 1 over gigantic, or gihugic. And 1 over a massive number, positive massive number or negative, is 0. So that's 2 plus 0, which is 2. So our limit is equal to 2. And sure enough, on the graph, what we actually just found is the horizontal asymptote. And we found that the horizontal asymptote, both to the right as well as to the left, is the same. And yes, you can have two horizontal asymptotes in a graph. So the horizontal asymptote, I'll call it the ha, is y equal to 2. Very neat. And that makes sense. Horizontal asymptotes are what happens as we look at the ends, E-N-D, of the graph, as we go to negative infinity and positive infinity. All right, let's keep rolling. It says find each limit, use your answers to write the equation for the horizontal asymptote for the function, if it has one. So again, we're going to use this conceptual idea of plugging in infinity, and we're going to take it a step further. So we're going to plug in infinity into here. Now, if I evaluate infinity into this, adding 1 to 3 times infinity, the 1 doesn't matter. Subtracting 2 from infinity doesn't matter. So essentially, this is basically the limit as x goes to infinity of 3x over x. That's an important distinction right there. The plus 1 doesn't matter, but only because we're plugging in a massive number. And 1 plus huge is still huge. Subtracting 2 from a huge amount is still huge. So this then divides out, and we've got the limit as x goes to infinity of 3. And this is a good conceptual way to think of it, which equals to 3. And if you look at the graph, sure enough, as we go out to the right infinitely much, we stabilize at positive 3. Let's use the same exact logic as we go to negative infinity. Still, if we plug in negative infinity, plus 1 doesn't matter, nor does minus 2 in the denominator. So essentially, only the leading terms matter in these operations. And you might have seen this kind of thinking before in a pre-calculus class. If not, here it is for you. So this will be about 3x over x. The x's divide out. And yet again, even though we're going to the left infinitely much, we're left with just 3. And so we see here on the graph that that makes sense. We do indeed have a horizontal asymptote at y equals 3. Boom. And the horizontal asymptote answers the question, to what y value, if any, does a function stabilize at, eventually approach, as it goes infinitely to the right as well as infinitely to the left? That's all. All right, let's do a couple more examples. So these are a little more beefy. We've got squared and we've got an x value. Again, though, I'm going to use the same logic I did last time, which is as we go to negative infinity, adding 2 to 5 times negative infinity doesn't make much of a difference. So you might as well be taking the limit as x goes to negative infinity of 5x over, and adding 2 to 3 times huge squared doesn't matter. So the leading terms take over. This logic, again, only works as x gets massive. This simplifies down. You have an x divide out with one of the x's in the denominator, and that's equal to the limit as x goes to negative infinity of 5 over 3x. Okay, well, if we plug in negative infinity, what's 5 over massive? Even though it's negative massive, it's still 0. And so that is a value of 0. Take, like, for instance, 5 over negative 4 billion. Yeah, it's negative, but it's really tiny. It approaches 0 as we go to the left. So we have one horizontal asymptote of y equals 0. Well, what do we have on this side? As we go to infinity, again, we know it still simplifies down. Same exact reasoning I just used. The limit as x goes to positive infinity of 5 over 3x. That doesn't change much. We still get, if we plug in infinity, 5 over 3 times infinity. And 5 over positive huge still goes to 0. So our horizontal asymptote, no matter which way you dice it up, is y equal to 0. And the graph confirms that. Awesome. All right, one last problem in this video. Find each limit. Again, use your answer to write the equation for the horizontal asymptote, if it exists. Now, let's take a look at this. Again, the leading terms are all that matters. So this limit is approximately the limit as x goes to negative infinity of, well, there's only one term in the numerator, so that stays as 2x cubed. The denominator, though, I get that there's another x here, but if I take a large number and multiply it by 2, and I take the same large number and I square it and multiply it by 4, take like 10,000. 10,000 squared is 1 with 8 zeros. 10,000 is just 1 with 4 zeros. That's far greater. And so the leading term, the highest powered term, is all that matters as we're going to the infinities. Well, this simplifies down to the limit as x goes to negative infinity of 2 divided by 4 is 1/2. X cubed over x squared simplifies down to x. Well, so now you basically have 1/2 times x. So that's 1/2 times negative infinity. That goes to negative infinity. So this limit does not exist. So there is no horizontal asymptote from the left side. Going to the left side. Let's check out the right side. Same logic. The limit as x goes to positive infinity of, it simplifies down to 1/2 x, based on the logic we used before. And so you're essentially now plugging in infinity. And that's 1/2 times positive infinity, which is positive infinity. So if that matters, it tells us that the graph as we go off to the right goes up, and as we go off down to the left, we go down. And sure enough, to the left and down, to the right and up. It's a beautiful thing. I'll see you in the next video where we're going to generalize this with some rules. They're probably the rules that your teacher taught you. I'd rather you do it conceptually like I just showed you, because then you don't have to memorize rules. Still, it might be worth going over those rules, and it comes from this kind of thinking. Peace. See you in a moment.